Hello, hello,
So,
hello, sir.
so, how
Hello.
are you?
Yes, I'm
How
fine, and you?
are you?
Now I can hear your voice,
Great,
so I'm really good. Thank
great,
you so much. Thank you so much.
great. Please just mute
Please
yourself from
just
the meeting.
mute yourself
Thus, we
from
only
the
talk here.
meeting.
Thus,
Oh,
we
okay.
only talk here.
Let me just.
Okay, and then I will share the
Okay,
screen
and
with
then
you.
I will share the
Now,
Yes,
screen with you.
I mute myself
now.
on the meeting. Okay, I can see. I can see everything.
Do you see what I have
Do you
already,
see what I have
shared
Yes,
already,
yes.
shared
now? You see
now?
the geometry?
You see the
Okay,
geometry?
okay. Yes, I can see the geometry.
See, this is what I have
See,
done.
this
This
is
is a
what I
simple
have done.
thing.
This
Okay,
is a
Yes.
simple
I think you
thing.
can make
Okay,
the 3D
I think you can make the
simulation,
3D
but this is a
simulation, but
simple
this is a
procedure.
simple
You can follow
procedure.
this procedure
You
and
can
conduct
follow
the
this
same thing for
procedure and
the
conduct the
3D
same
one.
thing for
Okay,
Oh, okay,
the
okay.
3D one.
Yes.
now
Okay?
you have seen that.
See,
I have
now you have seen that
created
I
in
have
the XY plane.
created
Mm-hmm.
in the XY
Yes.
plane.
If you want to make axisymmetric,
If
you
you
have to
want to
do
make
with the
axisymmetric, you have to
XY
do
plane.
with
Okay,
the
you make a sketch.
XY plane. The
Yes.
sketch
Okay, you
is
make a sketch. The
1,000
sketch
length
is
Yes.
and
1,000 length
40 millimeter
and the
40
radius.
millimeter.
As you said
The
that it is
radius.
for
You said that it is
80
for
I mean 8 centimeter, right?
80.
I mean
Come
8
again.
centimeter, right?
Come again, please.
The diameter is 8
The
centimeter.
diameter is
Yes,
8
yes, exactly, exactly.
centimeter.
Okay, of the smaller.
Cylinder.
Of the
So
smaller
8 centimeter.
cylinder.
So
You know,
8
you divide
centimeter.
it. You divide
Divided.
by two.
You know why?
By
Because
two.
we already
You know
make
why?
a
Because we already
axisymmetric. When
make
you make
a
a
axisymmetric.
axisymmetric
When you make
design,
the
or
axisymmetric,
you
the,
need
to
to
sketch
design
the
or
radius of it.
to
You
sketch
understand that?
the
Yes, I got you.
radius of
I
it.
got you, sir.
You understand that? Yeah, because
See, if
yeah,
we
because
want to see,
if we want
we
to
want to
revolve, if we want
both
to
of the sketches,
revolve
Yeah.
on this
both of
axis
these
about
sketches,
this axis
on this axis,
there will
about
it will
this axis,
become a
there will
it will
cylinders,
become
right?
a
Yes.
and
two
the
cylinders,
cylinders will
right?
be having and
This
the
is
cylinders
four.
will be
This is
having
four. This is
four
centimeter.
and
This
the
is
other
four.
four will be
Centimeter.
and the
So
other
it will
four will
complete from
complete
the
a
bottom.
complete
So it
circle
will
of
complete a complete circle
8
of
centimeter, right?
Yes.
So
8
in the
centimeter, right?
2D X, so
Symmetric,
in
you
the
need to
2D
make
X,
symmetric.
only
You
half
need
of the
to
geometry,
make
right?
All right.
Only
this is
half of
for
the
as
geometry,
we have
right?
seen
So this is
here.
for as
We
we have
see
is
for
for
that means in millimeter
is
is
for
for that means in
then
millimeter
we go
is
to
for.
the next one. Then
Yes.
you
We go
make
to the
another
next one.
sketch.
You start
You
the
make
sketch from
another sketch.
you start the
The
sketch
end
from
from this
point,
the end
and
from this
then you drag it until
point.
here, and
Then you
then you
give
drag it
also
until
the
here.
diameter.
Then you give
The length
also
is
the
gonna be the
diameter.
same length as
The
the
length is
bottom
gonna be
one,
the same
Yes.
length
but
as
the
the bottom
diameter
one.
but
The
the diameter
you take
a
the
dimension
see,
from here.
you take a dimension
General
from
dimension.
here, a
You take this
dimension,
point
general
and
dimension, the
you
axis,
take this point
and you
and
drag it like
the
that. It
axis,
will be
and you drag
150.
it like that. It will
Yes.
be
This is
150.
half of the
This is
300, which
half
means
of the
330
300, which
centimeter,
means
right?
Right.
30.
Centimeter, right?
Did you get it right now, or you have some
Did you
problem
get
with
it
that
right
with the
now, or
design?
you have
No,
some problem
to
with that
design,
with the
I
design?
can set it. I can set it out.
Great, great,
Yes.
Okay, great. So
great,
now we
great.
go to
Okay,
the
great.
so now we
We
go to
go
the
to the
meshing.
go
Okay,
to
you
the
you open the
meshing.
meshing.
Okay,
Yes.
You
you
open the
come over
meshing.
here. You have two.
You come over here.
You
Before
have
that,
two.
you need
Uh
to
huh. Before
combine
that,
both.
you need
The
to you
combine
need
both
to select
the
both. You
the
need to select both
you
this,
make surface
the
from them. You make
you
surface
select
from them. Both the
you
sketches. You
you
select
go to
both the
concept.
sketches.
Yes.
You
You
say
go to
concept.
surface
You say
from
sketches.
surface
So
You see
from
the
this one.
sketches.
yes, yes.
You
Like
see
you
this
make in
one.
one part.
Surface. Yeah,
Surface.
and no,
That means
yeah,
you make
and no,
the
that
two
means you make
sketches.
Uh huh.
The
as
two
bodies,
sketches.
Ah.
right?
So now we
Yes.
As
have buddy.
bodies,
Ah.
right?
Right.
And
So
this is a
now we
body.
have buddy.
Okay. Okay. Yes.
Buddy, and
Yes. I
this is
got
a
you.
buddy.
Okay. See, if I suppress this,
If I
see,
suppress
if
it,
I suppress
you will
this, if
not
I
see
suppress it,
any
you will
3D
not see any
design. See,
3D. You will only see sketches.
design.
See,
See,
you
Yes.
will
Yes.
only see
you
Yes.
will
sketches.
see
See, only sketches. You
So
will see
after
only
making
sketches.
the
So
surface,
after making
surface
the
from sketches,
surface here,
surface from
and you
sketches,
select both
from
the
here,
sketches and then
and you
generate,
select both the
you will
sketches,
get
and
this.
then generate, you will get
This.
the
You
two
will
body.
get
After that,
this
see, two body.
they
After that, see,
at the point that
they
you
at the point that
create
you
the
Pardon, s'il vous plaît,
bodies,
s'il vous plaît.
they are
create
not
the bodies
connected to each
they
other.
are
I mean,
not
they're not connected to each other.
made
I
as
mean, they're
one
not.
part.
So you need to make them
As
as
one
one part.
part.
So you need
You
to make
select
them
both the
as one
bodies
part.
and click.
You select
Right
both
click.
the bodies
Yes.
You say
and
click.
select
Right
both the
click.
bodies.
You say
Okay, right click
select both the
and
bodies.
make
As one part.
and
Okay.
This is
make
not
as
you
one
know
part.
shown here because
This
I
is
have
not
already made the
shown
part.
here because
So you
I
make
have already made the
as one
As
part.
one
So
part.
you make
Okay.
as one part.
Okay.
Okay,
To
sir.
be like that. See,
Okay.
to be
All
like that.
as
See,
one
to
part.
be
Why? What is the
all
reason of making
as
them
one
as
part.
one
Why?
part?
What is the reason of making them as one part?
The
Do
reason.
you know?
Yeah. Yeah. Yes, I know
Do
the
you know?
reason. Like it's gonna be too
For the
much. It's
meshing.
gonna be too much.
It's only for the meshing.
For the meshing.
Yes,
It's
for
only
the
For the
meshing.
meshing.
Yes, it's for the meshing.
You see in the meshing.
see,
In the meshing.
Mhm.
You
In the
see this
meshing,
point.
in the meshing,
You see this point.
see this point?
Yes. Yes.
See this point. Point of
This is the last
point of
this is
the
the last inner cylinder.
point of
Oh,
the
okay.
and also
inner
this
cylinder.
is and also this is the
Hello, sir?
last
Yes. Okay.
what the last
Last
point of the
what
we need
the last
to
point
of
these
the
two
we need
points
to
connect
we don't want
these
this
two
line
points.
to be like
We don't want this
line to be
here
like
and
this line to be here and
Hello.
this line to be here, okay?
Okay,
So
sir.
we
This
want to be here, okay? So we want
You
to
make them as one part.
Yes.
you make them as one part. You will not get.
Don't make them
Okay.
as one part. You will
Okay.
not get.
What I have done is
Okay.
I open
What
the
I have done
meshing.
is
Yes.
After
I
open the
open the
meshing,
meshing,
after open the
mesh
and then right open the mesh and then right click,
Mhm.
right click, click,
Yes.
right click,
Hello.
D.
Okay.
D. Okay. So, oh, I'm sorry. Okay. So,
Okay. Are you with me?
Yes, I'm
Are you with
recording.
me? In the geometry here, meshing in the geometry here, you need to select two faces. Volume, no, it is a face. You come from here. Volume, no, it is a face. You come from here.
Yes.
You select both faces and come here and say apply. Come here and when you apply, come over here. When you apply, right click, come over here, generate mesh. Right click and when you generate mesh. The mesh will not be like that. Then the meshing will not be like that. Then the meshing will not be like that. Depending on the meshing will be depending on the
Sorry, sir.
Oui, allô, c'est qui là?
size
Ah, là,
size
d'accord,
that you
excusez-moi.
have
Je vous rappelle dans
you
une
know
minute.
that you have
Excusez-moi.
Hello. Ah. Hello. Hello, sir. Sorry.
Hello? Do you hear me
sir,
now?
Yes, I can hear
Hello?
you.
Do you
Sorry,
hear me now?
I received a
Okay.
call like.
Do you hear me?
Yes, yes.
Okay. Do you hear me?
the internet.
But
Yeah, the internet.
I lost your video.
Okay, that's okay. So we have come to the. It's okay. So we have come
I
to
can't
the.
see-
Are you recording?
Yes, yes.
Are
yes.
you
Now-
record-
Now I can see what you're doing. But can you like come back a little bit? Can come back like from the mesh, like from the part
Brother.
Yes,
Are you
Brother.
recording?
yes, I am. Yes,
Are
I
you
am.
recording?
I'm recording. I'm recording. Hello. Hello.
Okay.
So the first thing we did.
Okay.
Yes.
We right.
So the first thing we
insert,
did,
and paste
we
meshing,
right
right?
click,
Yes,
insert,
yes.
and
Do you hear
paste
me?
meshing,
Yes, I
right?
can hear you.
Hello.
Do you hear me?
Yes, hello. Yes,
Hello.
I,
Do you hear me right now?
Yes, I can
hello,
hear you.
hello.
like,
Do you hear me
clearly.
right now? Okay. So did you know what we have done with the paste meshing? Did you know what we have done with the paste meshing?
With the face meshing? Yes, like from the geometry,
Okay.
you mix like the both parts,
Okay.
and you come to the mesh. But I didn't see what you did. Like
Yeah.
like,
After the meshing.
yes.
Yeah. After
No,
the
I
meshing.
didn't
After
see
you
like
came
the
to the
meshing.
meshing.
Yes.
After you came to the meshing, you
Mhm.
right click on the meshing.
Okay,
Insert.
okay.
Face meshing.
And the
Okay.
best meshing, you need to select
And the
two
best
faces.
meshing, you need to select two faces. And the geometry, you need to select two faces. So you come over here to the
Mhm.
face selector. You
Yes.
select this and select
You
this.
come over here.
And then
say apply.
you come over here.
Then after
You say
that,
apply.
you
Okay.
say generate.
Then after that,
After
you
generation,
say
the
generate.
the mesh.
After
You will
generation,
get a mesh, but,
generating the mesh,
a
you will
mesh
get a mesh, but
that is different from
a
here.
mesh
Okay.
Why?
that is different
Because
from here.
You need
Why?
to
Because
manipulate
you
the
need
element size,
to
okay?
manipulate the element size. Okay.
Yeah, you can go with 2 millimeters.
Yeah,
or
you can go
3,
with
4,
2
1
millimeters
It
or
depends on
3,
the,
4, 1 millimeter.
actually
It depends
the
on the
power of your
actually
computer,
the
okay?
power
If your
of your
computer is a
computer.
powerful
Okay.
one,
If your
you can go
computer
with
is a
1
powerful
millimeter
one,
or
you can go with
more.
1 millimeter or more.
Whenever you decrease
Whenever you decrease the size,
Okay.
it will be more
elements.
meshing
So if you see
elements.
light,
So
over
if
here,
you see
it is
light,
37,
over here, it is
around
37,000,
elements.
around
Okay, you can go
38,000
more.
elements.
I know
Okay,
in the
you can go
3D,
more. I know in the
simulation
3D
meshing,
simulation or the
having
3D
a much,
meshing, you
much
will be
more
Yes.
elements
having
than
a
this.
much more elements
Yes,
than
I got
this.
you.
Okay,
So we have done the
okay. So we
meshing.
have done the
I made
meshing.
a 2
I
millimeter
made
to get
a 2
a simple
millimeter to
kind
get
of meshing,
a simple kind of meshing,
and yet it is
and yet
acceptable.
it is
Yes.
kind of acceptable.
Now we need to
Okay.
make the
Now we need
boundary
to make
conditions.
the
This is the inlet,
boundary
right?
conditions.
You're
This
right,
is the
you're
inlet,
right.
right?
This is the outlet.
Yes.
This is the outlet.
See, this is something
See,
I called
this is
adia.
something I called
in the top
adia.
one and
This
the
one
side
in,
This
in
is
the top one
adiabatic.
and
I
the
mean,
side one.
this
This
is
is
not
adiabatic. I
going
mean,
to have
this is
any
not
heat
going
transfer,
to
right?
have any
Okay,
heat
yes,
transfer,
yes.
right?
Like not from the outside,
Yeah, there's no
only
heat
from the
transfer.
inside. Yes,
Yeah,
exactly.
there's no heat
Yeah.
transfer. So,
This is a
yeah.
couple.
So
This is a
this
couple.
is a
You
coupled.
will,
This is a couple.
you will already
You will,
have this as
you
a
will
coupled
already
wall
have
in
this
the
as a
setup.
coupled wall
Okay, this is a
in
couple.
the
I
setup.
called it
Okay,
a
this is a
couple.
couple.
It means
I
a wall
called it a
that is
couple.
coupled
It means a
between this
wall that
fluid
is
and this
coupled
fluid.
between
Okay?
this
Okay,
fluid
okay.
and this fluid. Okay. you need to also
You
specify the
need
axis.
to
It
also
should be.
specify the
An
axis.
axis could
It
be,
should be.
specified
And the
here.
axis could
This is
be,
the axis. I
specified
mean, this is
here.
the
This
axis
is
of
the axis.
rotation.
I mean,
If
this
I
is the
rotate
axis of
both
rotation. If I rotate both
both bodies
bodies upon this axis, you will get a really full
right?
two cylinders, right?
Okay, so and now
Okay,
these
so and
these are
now
only
these are
paces.
only
I mean,
the
not paces here.
faces. I
We
mean,
don't
not
deal with
faces
faces.
here.
We deal
We
only
we
with
don't
edges,
deal with
right?
faces. We deal
So with
only with
edges.
edges, right?
Yes.
Okay.
So with
Now
edges.
you need
Okay. Now you need
to name the bodies here,
to
the
name
volume.
the
Yes.
buddies
Go with the
here,
volume of
the
the
volume.
PCM. You
You
go
go with
over
the
here,
volume of the
right click,
PCM. You go
and
over here,
create
right
name
click,
selection. Then
and
you call it
create
PCM.
name selection.
Also, you
Then
do
you
this
call it
for the air,
PCM.
right click,
Also, you
and
do this for
name
the air,
selection, and
right
then
click,
make
and
it as air.
name selection, and
Only
then
call it as
make it
air.
as air.
One
Only
thing
call it as
before we
air.
proceed,
One thing
I
before we
forgot
proceed.
something
I
in the
forgot
designing,
something in the
in the
designing,
geometry.
in the
You have
geometry. In the
both
geometry, you have
buddies
both
as if you notice
buddies
here,
as
they
if you
they will
notice
be
here,
solid.
they
The
they
first
will
time
be
you
solid.
create
The
these
first
buddies,
time you create these
they
buddies,
would appear as
they
solids, right?
would appear
The
as
type of
solids,
them.
right?
So you
Yes.
need to
The type of them.
change them
So
to
you need to
fluid, right?
Yes.
change them
Yes.
to
I
fluids,
need to
right?
keep both,
Okay.
like to
And
both
then
the
you
three.
go to the
Okay.
yeah,
And then you go
both
to the
be as fluid,
yeah,
and then you go to the
both to
meshing and
be
do
as fluid, and then you go to the
things that
meshing
we
and do
already
the things that we
have done it
already
Yes.
right now. So,
have done it
and now
right
we
now.
go to
So,
the C.
and now we go to
You go
the
back to
C.
the
You go back to
the workbench. You
to
after
the
that
workbench.
first you
You
need to
after that
first
you need to
go back
see
to the
see see.
machine.
You need to go
You
back
need to
to the
right click
machine.
and
You need to
update.
right
You
click
wait a little bit
and
and it is
update. You
already
wait a
sent
little
to
bit
the
and it is already
solution,
sent to
right?
the
Yes.
solution,
Now
right?
we come back over
Now
here, right click,
we come back
and
over here, right
see
click,
how many cores
and
do you have in your
see
laptop.
how many cores do you have in your
I
laptop.
didn't check. Like I'm not sure. Yeah, I'm not sure yet.
See,
Yes, I
when
think
you
it's a
open
one
the
processor.
setup,
Yes, sir.
when
When you open the setup,
when you say edit, I mean,
when you say
even if you
edit,
double
I
click
mean,
on it, right?
even if you
It
double
will
click
not
on it, right?
show like that
It will
because I
not
have already
show
opened
like that because I have
the
already
solution. But you will
opened
get the
the
number
solution.
of
But you will get
cores
the
that
number
you need
of
to put
cores
the
that
number
you
of
need to put the number
wait,
of
No,
wait. Oh no, I want
I
to.
got you. I got you.
Oh no,
But I
no.
think it's a one
okay.
processor. Like
So you
yes.
to know them,
Okay, so you to know them,
you need to
to know
right
them,
click on
to know
here on
them,
the
you
task
need to right
bar.
click on
Yes.
here
You
on
go
the
to the
task
task
bar.
manager.
You go to the task
Then
manager.
you go to
Then you go to
performance. Where is it? Yeah.
performance.
You go to
Where is the
performance,
yeah?
right?
You go to performance, right?
And then you come over here to the CPU.
And then you come
Not the
over here
memory,
to the CPU, not the memory, to the CPU.
See, I have got
See,
the
I have
24
got
cores,
the
32
24 cores,
threads.
32
Okay.
threads.
Okay. I guess
So
I
you
can
need
see
to
that.
know how many cores.
So
do
you need
have
to
in
know
here.
how many
And
cores
spot
do you have in here,
If
and
you have
spot
two
you
cores,
see
Yes.
write
if you have two cores,
in
write
there. Write two.
two
If you
cores
have
in
four,
there.
write
Write
them
two.
four
If
in
you have
when you
four,
open the setup.
write them four
Okay,
in
okay.
when you
Four
open
and
the
open
setup.
the solution.
Okay,
I got
write
five.
four
I
and
got
open
five
the
core.
solution.
It's a HP. 5 core.
Okay, great. If it is five, then five.
Okay, great. If it is five, then five.
So we have opened.
Okay.
We have opened.
So we have
the,
opened. We have opened the.
we have opened the what?
We have opened the what?
The
We have
setup,
opened
right?
the setup, right?
In here
See,
we have transient.
in here we have
take
transient.
the time as
You have to
Yes.
take the time as transient.
Yes, sir.
This is
the second
first.
in the 2D
The
space. You need
second,
to make
in
it
the
as
2D
axis
space, you need to make it as
Yes.
axis symmetric,
Yes.
axis symmetric.
right?
You need
Axis
to
symmetric.
enable the gravity.
You need to enable the gravity.
I
But
didn't
see,
include the
I
gravity
I
for
didn't
the first
include
time
the
because
gravity for the first time because
it wasn't
it,
shown
it, it wasn't shown.
It was problem. I didn't.
It was
I
problem.
confused about
I
the
didn't.
first time
I was
because
confused
the
about
first
the
time I
first time
enabled the
because
gravity,
the
it
first
was
time I
only on the
enabled the
x-axis.
gravity, it was only on the x-axis. You know, it was only the y-axis was not enabled. So
Yes.
when you enable the gravity, if you have got both of the x and y accelerations and the component, then you're good. You only need to say minus
Yes, sir.
9.81,
Yes.
right? You only need
If
this.
you
This.
got both of
If
them,
you
you only need
got
to specify it
both
for
of them,
the y
you only
direction.
need to
If you
specify it
couldn't
for
and
the
you
y
only
direction.
got
If you
a
couldn't
x
and you
direction,
only got
make the
a
gravity
x
as zero
direction,
in the x
make the
and leave it
gravity
as it
as
is.
zero in the
Okay?
x
Okay,
and
okay,
leave it as it is.
yes.
Okay?
So we have
So
transient,
we have
axisymmetric. Now go to
transient,
models. In the
axisymmetric.
model,
Now go to
you need
models. In
T.
the model,
You need to
you need
right click on
T.
energy and
You need
on.
to
It
right
was
click
off,
on energy
you
and
need to
on.
enable it,
It was
right?
off.
Right,
You need to
right.
enable it, right?
The viscous, you can do
The
whatever
vis-
you want.
the
Yeah,
viscous,
You
you
can
can
go
do
with K
whatever you want.
epsilon,
You
yes.
can go with K
realizable, enhanced.
epsilon,
You can go with K
realizable,
omega
enhanced.
only.
You can
Okay?
go with K
Okay,
Okay?
omega
okay.
only. Okay?
Whatever you
You
want.
can
Can I also go with the
whatever you
laminar,
want.
the laminar one?
Okay?
With the
No, 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 you cannot.
I
You
No,
cannot.
never
no, no,
can.
you cannot.
Yeah, yeah, okay. With
You
the
never
laminar, I
can.
cannot.
No, 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 CT.
No,
You
no, no,
have
CC. So
you
you
have the
have
Reynolds
Yes.
you
is
have the
around
Reynolds
2. It was how
is
much?
around
22
two.
or
It was how
200,000.
much? 22 or 200,000.
Oh, okay.
How much was it? The
Uh,
velocity is
How
equal
much
to
was it?
1 meter
The
a second.
velocity is equal to
And
1 meter a
at that,
second.
I think you have
And at that,
already
I think you
sent
have
me the.
already
Let's see.
sent me
How much
the.
was the
Let's see.
velocity, the
How
Reynolds
much
number?
was the velocity, the Reynolds
okay,
number?
the hair.
It was
Here.
22,000.
It was
Yes.
22,000.
22,000.
22
22,000.
0
22
5
0
4.
5
You know this
4.
number is
You know,
what?
this
This
number
number is
is what?
turbulent.
This
Yes.
number is
Okay. Okay.
turbulent.
Yes. Yeah, I got you. I got you. So I can't like
You
make
know
it
about
laminar.
Reynolds number? You know about
You
Reynolds
know
number?
about Reynolds
Yes.
number?
Yes.
You know about Reynolds number?
It affect. It's like it affect the convective.
Smaller than 2,
More
300.
than
Yes.
2,
Smaller than
300.
300. This
Smaller
is
than 200,
laminar.
300.
Oh,
This is
okay.
And
laminar.
larger than
And
Yes. Yes.
2,
larger than
300.
2,
It is
300.
turbulent.
Turbulence.
It
Yes.
is
If it
turbulent.
is laminar, which is not
If
our
it is
case, you
laminar,
only go to
which is not
laminar
our
and
case,
okay,
you
and
only
go
go to
ahead and finish.
laminar and okay and go
No,
ahead
If
no,
it
and
is
no. It's fine. It's
turbulent,
finish your
fine.
work.
Yes. Yes.
If it is
our
turbulent,
case, you know,
as of
Yes.
you
our
need
case,
to
you know,
consider.
you need
See,
to
these
consider.
models
See,
are all for
these
the turbine.
models
This
are
one,
all
2,
for the turbine.
3, 4,
This one,
5,
two,
Yes.
three,
6,
four,
7,
five,
8.
Mm-hmm.
You
6,
got 8
7, 8.
models for
You
the
got
turbine,
8
but
Yes.
we only
models
deal
for
with
the
K
turbine,
epsilon and K
but we
omega.
only
Okay.
deal with K
You
epsilon
got
and
me?
K
Yeah.
omega.
You
I
only
got you.
You
deal with
got
K
me?
epsilon
You
or
only
omega.
deal with
Okay,
K epsilon
so
or
it's
omega.
up to you.
Okay,
You want to
so
go with K
it's up
epsilon.
to you. You
There's
want to
also
go with
models
K
in the K
epsilon.
epsilon.
There's
Standard,
also models in the
RNG,
K epsilon.
realizable.
Standard, RNG,
Realizable is the more,
realizable,
the most
realizable is the more, the most
acceptable one in the
acceptable one
reliable one.
and the
Yes. Yes.
So in the near
reliable
wall
one.
treatment,
Okay,
we
so
go
in
with
the near
enhanced
wall
wall treatment.
treatment,
This is
we go
better
with enhanced wall treatment.
because
This is
the
better
in the meshing,
because
Yes.
see, in the
we have
meshing,
these
we
these
have
wall the
these
see,
wall the where is it? See,
see
where is
this
it?
point. I mean
See
these
this point. I mean
these
these
lines are
uh
pretty
these
close
lines
to the
are
wall.
pretty
Okay,
Yes.
close to
so
the
when
wall.
it is
Okay,
pretty
so
close, you
when
need
it
to
is
go
pretty
with what?
close,
You need to go with
go with what? You need
enhanced
to
wall.
go with
Okay,
enhanced
and
wall.
this is I
Okay,
think I don't know if you know
and this
about it.
is I
This
think I don't
depends
know if
on
you
the
know about it.
y-axis,
This depends
y
on the
plus and stuff
y-axis,
like that. If you
y
have read
plus
them,
and stuff like that. If you have
Okay.
read
So
them
I got you. I
before.
got you.
do you know about y-axis?
Do you know about
Not really.
y-axis?
Not really. But I will
Not
learn.
really. So you need
Yes.
Not really. So you need see,
I want to let
see,
you know
see.
about
I want to
Okay.
let you know about
um
something. Okay.
be
Um,
informed about what is
you
Reynolds
know, be
number.
informed about what is
What
Reynolds
is Reynolds?
number.
Yeah, I mean, get a little bit
What is Reynolds?
deeper
Yeah,
in it.
I mean,
Okay,
get a
to
little bit
understand what is
deeper in it.
Reynolds
Okay,
number,
to
and
understand what is
go
the
with K
Reynolds number.
epsilon.
And
What is K
go with K
epsilon?
epsilon.
Which is
What is
this
K
one.
epsilon? Which
What
is
is K
this one.
epsilon? You need to
What is K
understand what is
epsilon?
K
You need to
Yes.
E.
understand
Tamam.
what is K
Okay,
Mm-hmm.
E.
and then
Tamam.
in the
Okay.
K
And
epsilon we
then
have
in
standard.
the K
Okay,
epsilon we
we
have
have
standard. Okay.
RNG,
We have
Yes.
and
RNG
we have realizable.
and we have
Okay, please
realizable.
go ahead
So
and check what
please
is K
go
epsilon
ahead
for the
and check
first time,
what is
and then
KFNR
what are
for the
these
first time.
three
And
models
then
inside
what
of it?
are
Okay,
these
which
three
one is the
models
best?
inside of it?
Okay,
Okay, which
Yes.
one is the best? Okay.
sometimes you go with the standard is the best. Sometimes
Sometimes you
the
go with the standard is the best.
RNG or
Sometimes
the most of the
the
time
or
realizable.
RNG or the most of the time
I mean,
reliable.
you just go a little bit deeper on
I
it,
mean you just go a little bit
and that's
deeper
will
on it.
be and that will be
Yes.
for your information. Okay. K omega also K omega. Also search about K omega and where do we use it? Okay. Sometimes you will find that the Kaplan is the most useful and used model for the turbine flow, and that depends on on some of the website that and some of the people that explain. Okay, so we go with the also the enhanced. Okay,
Yes,
go
I'm
ahead
listening.
and check this one. Go ahead and
This is pretty important.
see. This is
Yes, I'm
pretty
listening.
important.
Yes.
You can go with the
Uh, what
you
is
can go
what
with
is
the
what
enhanced.
is
What
wall
is enhanced
treatment? Okay,
wall
Yes, yes,
you
yes.
understand it.
treatment? Okay,
And then in
you
the same
understand it.
way, you
And
will
then
go
in
with
the
the
same
Y plus.
way, you will go with the
This
Y
is
plus.
related to this. You
This
understand?
is
Yes, yes, I
related
got
to
you.
See,
this.
Yes.
You understand?
in the
See,
in the wall
in the
treatment we have
in
standard
the
wall
wall
treatment. This
treatment
is
we
the
have
most
standard wall
used
treatment.
one.
This is the
Okay,
most
Yes.
both of them.
used one. Okay,
The standard and the
both of
enhanced.
them.
We don't use
The
much
standard
more
and
of
the
a
enhanced. We
scalable
don't
or
use much more
non-equilibrium.
of a
Okay,
scalable or
we
non-equilibrium.
always
Okay,
or
we
usually go with the
always
standard
or
or
usually
enhanced.
go with the
So
standard
if
or
the Y
enhanced.
plus
So
is
if the Y plus
a
is
range of number, okay,
a
you go
range of
with the
number.
standard. If it is
Okay,
more
you
than
go
some
with the
number,
standard.
no, you
If
go
it
with
is
the
more than
enhanced.
some
You
number,
understand me?
no,
Yes,
you
I
go with
got
the
you.
enhanced. You
Okay, so
understand
it
me?
depends on the Y plus. So
Okay,
how do
so it
you
depends on the
calculate the
Y
Y
plus.
plus?
So
There
how
is
do you
only a
calculate the Y
website,
plus? There
a
is
complete
only a
website. You
website,
see,
Yes,
a
if I go
complete
back
website.
to
You
the,
see? If I
you,
go back to
you go,
the,
see, I have already
you go,
saved
see, I
it
have
in
already
here.
saved
Where is it
it
here? See,
in
this is a
here, where it's
website
here.
for
See, this is
the
a website for
Y plus
the
calculation.
Y plus
Sorry to
calculation.
ask you.
Okay, this
Did you
is the,
calculate it for this
okay, this
project?
is the,
No, I did not. I did not. But
Okay.
no, no, no,
if
I did
you
not. I did
want
not.
to
But
be
if
more
you
of
want to
deeper,
be
go deeper,
more of
Yes.
and more
deeper, go deeper and more
appropriate for your work,
Yes.
you can go with
appropriate for your
calculating
work,
the.
you can
But
go with
I think
calculating
you're
the.
not gonna
But
need it
I
right now.
think
But
you're not gonna
you
need it
wanna gonna
right now. But
you wanna need it only
you
for
wanna
the information.
you
If
wanna need it
somebody
only
asks
for the
you, or
information. If somebody
Yes.
asks you, or
in the
you
master,
know
you are
the
studying
in the
master,
master,
right?
you
Yes.
are
Yes.
studying master, right?
So somebody has asked you
Ah,
about
so
that. You
somebody
need to
has
know it,
asked you
right?
Yes.
about that.
I'm aware.
You
In the
need to know
future,
it,
if
right?
someone asks you about,
In the
do you
future,
know
if
about
someone asks
the
you about,
Y
do
plus?
you know about
Did you
the Y
calculate Y
plus?
plus?
Did you
In that case,
calculate Y plus?
okay,
In
Yes.
that
the
case, okay, the
you will be able to
you will be
answer.
you will be
Say
able
yeah, the
to
Y plus is
to
only
answer. Say
a
yeah, the Y
measurement
plus
of
is
the
only
C.
a measurement of
We have
the
this is
C.
pipe. Okay,
We
this is
have
the
this is
fluid,
the pipe.
and there is
Okay, this is a
a
fluid,
thin
and
layer
there
over
is
here. So
a
to
thin
calculate
layer over
the
here.
layer here
So
in
to
the meshing,
calculate
I mean,
the layer
so as
here in the
to put
meshing, I
a
mean,
number for
so
the
as to
layers
put
here,
a
you
number
need
for
to
the
calculate Y
layers
plus.
here, you
Okay,
need to calculate
you
Y
need
plus.
no, it is
Okay,
not calculated.
you need
It's
no,
not
it is
calculated.
not
You give it a
calculated.
number.
It's not
Y
calculated.
plus,
You give it
give
a
it a number.
number.
I
Y
go
plus,
with one.
give it a number.
I go with
I
one.
go with
Okay.
one.
Okay.
So
I go with one. Okay.
when you put
So
here one,
when you put
the
here one,
characteristic length, this is the
the
diameter.
characteristic
It
length.
is
This is the
O
diameter. It is
point
O
O how much?
point O how
O
much?
point O eight, right? This is the diameter of
0.08,
the air
right? This is the
cylinder.
diameter of the
The
air
dynamic viscosity of
cylinder.
the air,
The
and this
dynamic
is the
viscosity of
density
the
of the
air,
air,
and this
and this
is
is
the
the
density
velocity
of
we
the
have
air,
at one.
and this is the
Okay.
velocity we
Yes,
have
I
at
got you.
one.
Depending on
Okay?
these input
Depending on
parameters, you
these
go with the
input
internal
parameters, you go with the
flow.
internal
See, here is
flow. See,
a
here
first
is
layer height.
a first
See,
layer
this is
height.
a first layer height,
See,
which
this is
means
a first layer height,
point, I
which
think it
means
is 0.4 millimeters.
I think it is
It is
point 0.4
0.4
millimeters.
millimeters.
It is
What does that
0.4
mean?
millimeters.
What does that mean?
What does
See,
that mean? What does that
just
mean? See,
focus a little bit with me.
just focus a little bit with me.
Yes, yes.
We
I'm
have
here. Yes, I got you.
We
we
have
have
I'm here.
this one.
Hmm.
See,
we have
we
this
have
one.
this one
See,
as
we
fluid,
have this
right?
one as
Right, sir.
But
fluid,
there is
right?
a wall
But
in
there
here.
is a wall in
You see
here.
it? This
Yeah.
is the wall, right?
Yes,
You
yes.
see it? This is the wall, right?
And these are
And these
the
are
layers near the wall.
the layers
These are
near
on
the
this is
wall.
this is one
These
layer,
are on
this is two layers,
this is
this
one
is
layer, and
This is 2
so on.
layer,
So
and this
these
3,
are the
and
layers
so on.
that are
So these are the layers that are close or near to
So
the wall. Okay.
what do you
So
mean by Y
what
plus?
do you mean by Y plus?
I mean,
And
when
why
you
did you
put a Y
put it?
plus in
I mean,
here,
when you
Yes.
put
you
a Y
want,
plus in here,
depending on the
you
Y plus
want,
that is
depending on the Y plus
one
that
is
is
the preferable one.
preferable.
Okay?
One is the
If you put
preferable one.
one
Okay.
and you put
If you
all
put one
other
and you
parameters
put
that are
all
already
other
put
parameters
in
that
the
are already
simulation, when you put
put
this,
in the simulation,
we
when
need
you
to
put this,
calculate
we need to calculate
where
what happened to the
anyways,
dynamic
let's go back.
viscosity. Anyways, let's go back.
It was 0.4, right?
It was
You will have
0.4,
this,
right? You will have
You
this.
will have this.
I'm
Yes.
sorry.
First,
You will have this.
layer height.
First,
How much
layer
was it?
height.
It was 0.
How much was it?
I will write
It was 0.
It was
I will write it in
point
here.
oh
It was
oh
0.004
4 meter.
Yes.
meter.
What does that mean? That means that
What does
if you
that
go
mean?
to the mesh
That means that
of your
if you go to the
simulation,
mesh
if you go to
of
the
your
mesh
simulation, if you go
that
to the
is
mesh of your
close
simulation,
to the wall,
the
this is
first
the
layer
wall.
that is close
first
to the
layer
wall, this is the
should
wall.
be
The first
from the
layer
wall,
should be
it should be away from the
from
wall
the
with the
wall,
distance,
it should be
distance
away
of
from the
how
wall
much
with the
of this.
distance of how
Okay.
much
Of the Y plus.
of this.
Because
Oh,
of the
yes.
Y plus that I considered as one,
Because
and
of
because
the
of
Y
the
plus that I
velocity, the
considered
dynamic
as
viscosity,
one,
the density,
and because of the
diameter of
velocity,
my
the
work,
dynamic
I
viscosity, the
want
density,
you,
and
the
the diameter
website,
of
I
my
want
work,
to
I want
calculate
you, the
the
website,
first
I
layer
want
height
you
for me.
to calculate
And by
the
doing that,
the
he
first
told me,
layer
the
height
website
for me.
told me that
And by
your
doing
first
that,
layer
he
height
told
should be
me, the
0.004
website told me that
meters.
your
That
first
means
layer height should be
0.4
0.004
millimeter,
meter.
right?
That means
Right.
0.4
If you make it like
millimeter,
that, it will be
right?
okay. It will be great.
If you make it like that, it will be
good.
okay. It will
Okay.
be great
So
and fine, and your work will be good. Okay. So
in the 2D,
so
simulation,
in the
in the
2D
2D
in the
simulation, to
2D
know
simulation
how much is the
in the 2D
distance between
simulation
this
to
and this,
know
you can come
how
over
much is
here,
the
not
distance
this
between
one.
this and
You
this,
can come over
you
here
can come over
and
here,
select 2
not
points.
this
This
one.
is the
You
wall,
can come over
and
here
this is the
and
point.
select 2
This is
points.
the first
This is the
layer
wall,
that is
and this is the point.
close
This
to
is
the
the first layer that
wall.
is
So let's see
close
the
to
distance between this
the
point and
wall.
this point.
So let's see the
How
distance
much
between
is
this
it?
point
It
and this
is
point.
how much? It is
How
2
much is it?
millimeter.
It is how
How
much?
much?
It is
2
2
millimeter.
millimeter.
That means it is
How
much
much?
larger
2
than
millimeters.
0.4.
That means it is much larger than 0.4.
So I mean, it is not
So
validated with the number,
I mean, it is
right?
not
Right.
validated
I
with
mean,
the number,
sometimes we call
right?
it not acceptable. Sometimes
I
we
mean,
call this is
sometimes
a
we
not
call it not
non-acceptable
acceptable. Sometimes we call this is a not
first layer height.
non-acceptable
So
first
what do
layer
you do to
height.
make it
So
point
what
two?
do you
This is the distance
what do
from
you
here
do
to here.
to make
What do
it
you do to make
point
it
two? This
point
is the distance from here to here.
2?
What do you do to make it
0.4.
point
Come over here.
2?
The element
Point
size.
4. You
And
come
instead
over
of 2
here.
millimeters, you can go with
The element size.
let's see,
And instead of 2
1
millimeters, you can
right?
go with like
Okay.
let's
Yes.
see 1 millimeter, right?
And to
If you make it
reduce
1, let's
yes.
go.
To reduce. Yes.
If you make it 1,
let's
let's go
generate.
Yes.
and
We can go with
and
generate.
let's generate.
If you come
We
over
can
here,
go with generate.
like this
Let's,
one, come over here.
if you
and
come over
say,
here, like this one,
this is
come
1
over here
millimeter.
and say,
It's acceptable. You can go.
This
you
is
can
1
say
millimeter.
acceptable because
It's
0.4
acceptable.
or 1.
You can
is
go.
acceptable,
You can say
right?
acceptable
Yes,
because
right.
0.4 or 1
This
that is
the
acceptable, right?
mesh that we have
So this
for
is the acceptable
the
mesh
simulation.
that
But
we
as
have
I have
made
only made
for
a simple simulation
the
for you,
simulation. But
I
as
went with that.
I have only
kind
made
of.
a simple
Okay?
simulation for
You
you,
can deal with it.
I went with
Now
that
what I have, why
kind
did
of.
I only,
Okay?
why
You
did
can
I
deal with it.
Now
Now, what I have,
deeper in the
why did I
Y
only,
plus and the
why did I,
matching and stuff? Because
go deeper in
one day
the
you will be
Y plus
asked
and the
about
matching and stuff?
what is the
Because
Y plus
you,
that you chose?
one
What
day you
is
will be
the
asked
first layer
about
thickness?
what
Someone
is the
was-
Y
will
plus that you chose,
ask you,
what
right?
is
So
the
you need
first
to
layer
know,
thickness.
to be
Someone will
aware of that.
ask you,
Okay.
right?
If you,
So you need to know, you need to be, aware of
apply,
that.
okay? Do
Okay.
not apply
If you
the
don't
Y
want,
plus as we
do
have,
not
already
apply.
explained.
Okay. Do
But
not
only
apply
to keep it in mind.
the Y plus
Only
as
keep it
we
in
have
your mind, okay?
already
You can go with this,
explained, but only to
2
keep it in
millimeters
mind.
or 1
Only keep it in your mind. Okay. You can go with this
element size. It
2
depends on
millimeters
the,
or
this,
1 millimeter
the power of your
element size.
It depends on the power of your simulation. The meshing is around. Let's see how much is the meshing right now. The meshing is around. The meshing is 150,000. It was how much was it? 37. See? Okay. So if your much larger than the deal with this or handle 1,000, you can go back to. So if your computer cannot deal with this or handle, you can go back to 2 millimeters. Okay, K-epsilon. And the realizable and the enhanced. Now go back to this. Okay, K-epsilon. And the realizable and the enhanced is a very good choice. Go okay, and then edit. Let's go to solidification and melting. Right click, edit. What? Now melting. Enable the model of solidification and what? And melt. Is it okay? And then go with okay. That's all what we need from this. So now is it okay? Menu. You go to the material. That's all what we need from the air. Menu. You go to the material. You go to the air. The air is already, taken as the standard one. Anything. It's already inserted. We don't need to change anything. It's already inserted as a fluid. No, you need to create another. The same air, okay? The same air. You can double click on the air and the same air, okay? The same air. And then come on, double click and say DCM. What I have done for the density, and then come over here. I made the density as positive. What I have done for the density, I made the density as positive. You can go with constant or you can go with bosonist.
No, it's better.
Okay. You can go with constant or you can go with bosonist. Yeah. So it depends. Okay. It also depends on the. Yeah. So it depends. It also depends on the validation. If you made a validation, you can go with constant or bosonic and see which one is the most validated one and give a good kind of acceptable result. So go with bosonist. Then write the first one is 780, 800, and then you write the DP and the solid one. Okay, this is the solid. 780, and then you write the DP, the solid one. Okay, this is the solid. This is the solid. This is also the solid. And now you go with the one, or also this is for the liquid, right? And now you go with the thermal expansion coefficient. You write it, and the melting solvent melting heat, and the see. The solidus temperature. Here are two important things. I will close this. The solidus temperature and the liquidus temperature. I will close this. I open the PCM for the positive material. See, I made 785 for the positive, 19 for the 1800 for the CP, 0.19 for the conductivity, and this is viscosity, 0.001 for the data. And this is for the fuse of the melting. Look over here. We got the solid temperature. What is the solidus temperature? This is the temperature at which the PCM is completely solid. I mean, if I specify the whole, the whole system. I mean, if I specify the whole, the whole system, if I after the initialization, when I go to the initialization, if I specify the whole temperature to be of the whole system as 299, that means that the air will be 299, all of it, and the PCM all 299, and the PCM will be solid or liquid.
Yes, I got you.
What is it? What is it gonna?
Hello.
What is it gonna be? What is it? What is it gonna be? If I make what is it gonna be? The PCM in this case. If I make the whole system initially as 299, is it gonna be liquid or solid? The PCM initially. Yeah, right. Because I said that the solidus temperature is 299. Yeah, right. More than 299. Because I said that the solidus temperature is 299. More than 299. More than 299. The PCM will be melting. You understand me? The PCM will be melting. Not all of it, but will be melting. Now, the liquid is temperature. That if you reach this temperature and beyond, let's say 303,
310,
Okay.
310,
If you reach
and
310,
let's say
and more than
311.
this will be complete what
If you reach
not completely,
310
but it's
and
just gonna
more
be
than 3, this will be complete what? I mean, not
90% of
completely,
it,
but it's gonna
or
be
95% of it is
like
melted.
90%
So
of it,
if you reach
or
312 or
95% of it is
315,
melted. So
320,
if you reach
this will be all
312 or
melted. Okay, so you
315,
specify
320,
both.
this
This
will
is
be
from you.
all
You
melted. Okay,
already
so you
provided that to me,
specify
but you
both.
didn't
This
provide
is
the
from you.
liquid
You
temperature of the PCM.
already
So I
provided that to
already
me,
made one
but you
for you,
didn't provide
310.
the
You
liquid
can go with
temperature of the PCM. So
whatever
I
you want. Okay, you
already
can
made
go
one
fine.
from me,
That's fine.
310.
333
You
as
can
you
go
made.
with whatever you want.
Okay.
Okay, you can go with 333 as you made. Typically sent me. You said that do you remember?
333.15.
Typically
Okay,
sent me.
but
You said that
this is written as maximum temperature. I don't know what
333.15.
is the maximum.
Okay,
Is it the
but
melting
this is
temperature?
written
If
as
you
maximum
if it is
temperature. I
like
don't know
that,
what
then
is
you
the
need
maximum.
to
Is
write
it
it
the
over
melting
here.
temperature?
So
If you
what is it?
if it is
So
like
that
that, then you need to
when the
write
air
it
comes
over
from
here.
here, the
So
air will
what
be
is it? So
3.
that
I mean,
when
the
the
air
air
should
comes
be
from here,
as a
the
temperature,
air will
right?
be 3.
Just focus with me, please.
I mean, the air should be as,
See,
as
the
a temperature,
temperature of
right?
the air, I don't
Just
know
focus
what
with
was the
me, please.
temperature of the air. You didn't
See,
write it for
the
me, right?
temperature of the
I
air,
made
I
it
don't
as
know what was the
330.
temperature of the air. You
The air
didn't
will be
write it
coming
for me,
as
right?
330.
I made it
Okay.
as
Okay?
333. The
So
air will
Then-
be
the
coming
air
as
is not
333.
melting.
Okay?
I need to
Then,
melt the
then
PCM,
I
right?
need
We know
to
the
melt
temperature of the air. It is
the
330.
I need
Yes.
to melt the
But
PCM,
if
right?
the
We know the
solidus
temperature of
is
the air. It is
299,
333.
then
But
ANSYS asks
if
you,
the solidus
says
is
that
299,
what temperature
then
should the
ANSYS
PCM
asks
reaches
you.
so
He says
as
that
to be
what
melted?
temperature
You
should
understand that?
the
Yes.
PCM
So
reaches
I say
so
that
as
when
to
the air
be
comes
melted?
with
You understand that?
333,
Yes.
So
it will
I say
will
that
what? It
when
will
the air
give the
comes
heat
with
from it
333, it
towards
will
the
it will what? It will
Then
give the heat from
I
it
say to ANSYS
to the
that
towards
consider
the
the liquid
PCM.
temperature as
Then I say
310.
to
That
answer
means
that
that when
consider
whenever
the
you
liquid temperature
any
as
cells in here
310.
reaches
That means that
310,
whenever
make it
you
melt it.
any
Okay,
cells
melt it.
in here
Yes.
reaches
So
310,
if the whole
make it
complete
melt it.
system
Okay,
reaches
melt it.
310,
So
the
if the
PCM will
whole
be
complete
melted.
system reaches
Okay, you got that?
310,
Got it.
the whole PCM will be
You can
melted.
you can go ahead.
Okay, you got that?
Your teacher or your supervisor
You
says
can
no.
go
I
ahead.
want it to be
Your teacher or your
333.15. This is
supervisor
the
says
maximum
no.
temperature
I
of the
want it to
PCM
be
at which it is completely
333.15. This
melted.
is the
You
maximum
say,
temperature
okay,
of the
that's great.
PCM
But
at which it is
but you
completely
need
melted.
to
You say,
say
okay,
that
that's
the
great,
air
but
temperature should be more,
but
a little bit
you
more,
need
you know,
to
because
say that the air temperature
I
should
think
be
that
more, a little bit more,
the
you know,
same
because
temperature
um
there's it's not gonna
I think
melt,
that
you know,
the
a lot of
same
heat.
temperature
So,
Yes.
for
there's
example, you go
it's
with
not
the
gonna melt,
inlet
you
temperature
know,
of
a lot of heat.
370
So for
or
example, you go with
350.
the
Yes.
You
inlet
understand me?
temperature
Yes,
of
I got it.
370
Okay.
or
That's
350.
the idea that
You
I want.
understand me?
No, no, it's fine. Like it's a
Okay.
perfect idea.
That's it. That's the idea that I
Oh,
want.
yes, that.
Um.
So we go back. The see
Oh, yes,
when
that
you
thing.
finish
So
the
we go back. The see
the materials,
when
inserting the
you
materials
finish
as
the
properties,
Yes.
you
Okay.
already
checking
had
of the materials,
air in
inserting
here.
the
See?
materials as the
Yes.
properties.
We already in the air.
You
We
already
haven't
had
created the
you
PCM
had
yet.
air in here.
We
See,
only changed the
see, we
properties.
already in the air. We
When
haven't
you
created
change
the PCM yet.
create, you click
We
change and
only
create.
change the
There will
properties.
be a pop
Do
up
when
menu
you
to
change
say yes
and
or
create,
no.
you click
You
change
need
and
to
create.
say no.
There will
Why?
be a pop-up
I will
menu
tell
to
you.
say yes
This is
or
the
no.
air. I
You
want
need to say
change
no.
the temperature,
Why?
the properties. Let's say
I will tell you.
let's
This is the air.
say
I want
this
to
is
change the
something
temperature,
like that.
the
This is
properties.
something
Let's
like
say,
that. Okay,
let's
let's
say
change
this is
anything in here.
something
Okay.
like that. This is
So
something like that.
when you
Okay,
say
let's
change and
change
create,
anything in here.
he says,
Okay,
do you
so
want
when
to
you
change
say
the air
change
delete
and
it
create,
make this
he
instead of
says,
it?
do you want
This means that
to change the
override. Do you
air
want
and
to
delete
override
it
the air?
and
Say
make
no.
this
No,
instead of
okay.
I
it?
wanted to create
This means that
another,
override. Do you want to override the air?
totally
Say no.
different,
I
material.
wanted to
So you
create
say no.
another
We already
totally
have this
different
TTT.
material.
See?
So you say no.
With its
See, we
placed,
already have this
property.
TTT.
So we need to
See,
delete it.
the with its placed properties. So we need to delete it. We
The
don't.
aluminum is not.
We don't want it. This one. You can go with delete. That's it.
Now we go to the
The
cell
aluminum
zone.
is not a thing here.
Go from here.
See, now we go to the
Zoom
cell
type.
zone.
No, the air should be
when you go from here to zoom type.
Right, right.
No, the air should be
When you double click, the air should be air, right? It's already gonna be air, so you need to change it to PCM. The PCM is already gonna be air, so you need to change it to laminar zone here. Consider the laminar zone here because the PCM consider laminar zone here. Consider the laminar zone here because the PCM is not turbulent. Keep that in mind. The turbulence is only for the movement of the air. Put that in mind. But the PCM, the turbulence is only for the movement of the air, the flowing of the air. But the PCM is not turbulent. The PCM will be melted and is not a turbulent flow. It is a laminar one.
Hello.
Okay.
Okay, sir.
Okay. Okay. You say apply. Okay. You say apply and close.
Yes, sir.
Okay. So we have. Okay. You say apply. Now you go to that. You say apply and close. So this is the axis. Okay, axis. It's already. Now you go to the boundary condition. The inlet is a velocity. So this is the axis. Okay, axis. It's already going to be axis. The inlet is a velocity inlet. It is the velocity inlet. You go with velocity of 1 meter, the temperature of 333.15, or whatever you want, or the master that specifies for you. Okay, apply and close.
You didn't
See,
put the pressure, any pressure.
you don't need to consider anything for the pressure.
Okay, sir.
You don't need to consider anything for the pressure.
Okay, sir.
See, it will be already calculated our work. Okay, and see, this is the flow. This is our work. Okay, this is our work, right? And if you see, at the first time you open this is our work, right? Inlet, axis, inlet. At the first time you open this, you'll be seeing inlet, axis, inlet, outlet, and wall. We don't need deal with the adiabatic. Do not do anything with it. It's already heat flux is already a pressure outlet. Do not go with it. We don't need it. As it is, the outlet is already a pressure outlet. Do not go with it. Here you will leave it as it is. The inlet we change it. The axis is the same as axis. But here you will see that the internal
but there is
of
one
air,
that was
okay,
coupled.
the internal of PCM,
we have
okay,
already,
PCM. But there is one that is coupled. You remember that we have already, given it as a name of couple. This one.
Yes, I remember.
This is between the air and the PCM. You remember?
Or solid.
Internal means the fluid,
Right? Internal.
or
Yes, yes.
solid. A complete fluid or
That
complete
means
solid,
coupled,
right? Internal. But couple, when you say couple, that means when you say couple, that means this is not a wall.
It is as
It's considered it as let's see, let's say it is as a sponge. The sponge could give water from it, right? So I don't want this. I don't want the air can pass water from it.
Right.
So I don't want this. I don't want the air to pass
PCM
to
melt
right?
and comes in contact with
Neither do I want the PCM to melt and comes in contact with the air. I want it to be a wall,
And
Okay,
this is
so
very
you
important.
come over here to the couples.
Very important.
You go to the interior, and this is very important.
Okay.
When you
Very
change to
important.
wall,
Yes.
it will be
And change it to
a
wall.
coupled wall.
See, when you change it to wall,
you can
it
give
will
it a
be
thickness also.
see,
Okay.
You can
coupled
give it a
wall.
thickness here.
See, it is a couple wall. That means you can give it a thickness
Okay.
also.
Yes,
Then
yes.
It
you
will
can
be
give it a
two walls.
thickness here.
Whenever, see, why we have the couple
Okay.
and the couple
Then
shadow.
it will be
why we
two
have
walls.
shadow. See,
Whenever,
in
see,
any
why we have the
simulation,
couple and the
Yes.
couple
in
shadow,
any
why
design
we
or
have shadow.
model, if you have two
In any
fluids
simulation,
are
in any design or
a
model,
direct
if you
contact,
have
Yes.
this is
two
a fluid.
fluids
This is a fluid.
are
And they are
in a
connected to
direct
each other
contact,
in a
this is a
direct
fluid,
contact.
and this
Is
is a
there
fluid,
any
and they are
thickness that we have designed in the
connected to
model
each
here
other
in
in
the
a
geometry?
direct contact.
We did
Is
not,
there
right?
any
Yes, yes.
We did
thickness
not
that we
place
have
a
designed in the
thickness
model
in
here in the
We
geometry?
only made
We
the
did not,
fluid of air
right?
and the
We
fluid
did
of
not
PCM.
place
So
a
you need to
thickness
make
in
this
here.
one. You
We
say to
only
ANSYS
made the
that I
fluid
want
of air
it to be
and the fluid
wall.
of PCM.
So when you
So
make
you
the
need to
wall,
make this
ANSYS
one. You
will
say
tell
to
that
ANSYS
the
that I
wall
want
is
this to be wall.
this wall
So
and
when
the
you
shadow
make the
of it.
wall,
Why?
ANSYS
Because the
will
wall
tell you
is
that
the
the
one
wall
that is
is
facing,
this wall and the
for example,
shadow
the
of
air.
it. Why?
The shadow is
Because
the
the wall
same
is
wall
the
that
one
is
that
facing
is
the PCM.
facing,
Okay,
for
yes,
example,
yes,
the
I
air.
got you.
The
Yes,
shadow
yes.
is the same wall that is
See,
facing the
let's
PCM.
open it and see. Hey mama daqiqa. tamam.
See, let's open it and see.
Okay.
Hey, mama, daqiqa.
To go to,
Tamam. Okay,
Okay.
sorry. Okay, they want me to go to If you open the couple, any wall you open, you go to adjacent
If
cells.
you open the couple,
This is the
any
name of
wall
it.
you open,
What
any
is
wall
the
you open,
adjacent
you
cell
go
zone
to
for the couple?
adjacent cell zone. This is the name of it.
Couple,
What is the adjacent cell zone for the couple?
I can't. I don't understand. Adjacent.
You see?
Yes.
Do you see what is the adjacent cell zone of the couple? It is air.
You
Yes.
see?
Yes.
Do you see what is the adjacent cell zone of the
Do you see
couple?
the,
It is air. You see
Do you
it?
see or not?
Yes. No. Yeah. I can see that. I can see that.
Do you see
Yes.
the?
Okay, so we got
do
to
you
the
see or
couple
not?
shadow.
Yes.
Let's see. What is the
Okay,
adjacent
so
cell zone
we
for
got
the
to the
couple
couple
shadow?
shadow.
PCM.
Let's see. What is the
See? So
adjacent
one
cell
is
zone for
facing
the
the air
couple
and one
shadow?
is facing
Okay.
the.
Yes. Yes.
See?
Okay.
So one is facing the air and one is
Before we
facing.
go further, there is
Okay.
operating condition that you
Before
need.
we go
importantly
further,
need to change.
there
If
is
you don't
operating
change,
condition
there
that
will be a
you
very
need.
huge problem
You
for you
importantly
for
need
the
to
bosonist.
change. If you don't
If
change,
you
there
ever
will be a huge
consider
problem for you
bosonist
for the
or
bosonist.
temperature for the
If you
density,
ever
you need
you
to
ever
change the operating
consider the
temperature to be
bosonist
the
for the temperature
you
for
know,
the
you can go
density,
with the
you need
cold
to
temperature.
change the operating temperature to be the you
So
know, you
see,
can go with
I
the
want
cold
you
temperature.
I want you also to
See, see, see.
search
I want you
for
I
the
want you also
search for the
I want you
operating
also to
temperature of bosonist
search
Yes.
parameter.
for the
Bosonist
search
density.
for the operating
Search on this
temperature
point
of
also.
bosonist
What is the
parameter.
operating
Bosonic
temperature of the
density.
bosonist density?
Search on this
And
point also.
some
What is
sites
the
will
operating
explain that for
temperature
you.
of the
Okay.
bosonic
Okay.
density?
And
And
explicitly, you can go with
sites
the
will explain that for
implicitly
you.
with
Okay.
the
And
say what is the
explicitly
temperature that I
you
should
can go
go
with the
with in the
implicitly
when
with
I deal with
the
the
PCM.
PCM
Say
and
what is the
bosonist?
temperature
Is
that
it
I
is
should
it the
go
cold
with
the
in
solidus
the when
temperature
I
or
deal
the
with the
liquidus temperature?
PCM and bosonist.
You understand?
Is it the
I
cold,
understand.
the solidus temperature, or the
So you can
liquidus
go with the
temperature?
solidus.
You
Or you
understand me?
can also, search first and no.
So you can go with a
Now
solid,
you say okay,
or you
and then
can also,
that's all done.
search first and
You go to the
nowhere.
method,
Now we say
you change
okay,
to
and
simple.
then
Sorry, sir.
that's
I have a
all
question.
done.
So, why
You
did
go
you
to the
choose
method, you change to
299
simple.
as a temperature?
Yeah, because the solidus temperature of the PCM is 290.
Yeah, because
Okay.
the solidus temperature of the
As I told you,
PCM
why
is
did I tell you
299.
that search for it?
Ye-
Because
yes.
maybe you will find some
As
sites
I
will
told you,
be
why did I tell you
saying
that
no,
search for
do
it?
not
Because
say the
maybe you will
solidus,
find some
put
sites
the
will be
liquidus temperature. You
saying that
understand?
no, do not
So
say
you need
the
to go with
solidus.
it
Put
because
the
there's a
liquidus
lot of
temperature. You understand?
misconceptions.
So you need to go with it
So you
because
need to
there's a lot
have
of
a little insight of it.
misconceptions
So you say
these
okay,
things.
and then
So you need to
so
have a little bit
here in the names
inside of it.
expressions,
So we
I
say okay,
made
and then we go out.
nested number
So
at
here in the names
stuff like that.
expressions, I
Yes.
made
So,
nested
how did you
number
do that?
Go
Like,
to
at
method.
you
stuff
create
like that.
expression.
What was
Go to method.
leave this for now.
Okay.
We
Okay.
only need to go. I will come back.
What was
Go to the method.
leave this
Change the
for
scheme
now.
for
We
a
only need to
simple.
go.
Okay.
I will come
Yes.
back to it.
What
Go
is
to the
that
method.
simple?
Change the
You
scheme
only
for
need to change
a
this
simple.
one and
Okay.
this one. The pressure
Put
as
it as
presto.
simple.
The presto is
You
for
only
the
need to change this one
natural
and this one. The pressure as
Okay.
presto.
Okay. So,
The presto is for the natural convection.
whenever you have a natural convection, go with presto. Okay. Now after
Whenever
that,
you
go
have
to
a natural convection, go
initialization.
with
yes.
presto. Okay.
You
Now
press
after
some
that,
inlet.
you go to initialization.
Okay. And then
You press
see,
some inlet.
you only need to change this
Okay.
because
And then
you want
see,
to initialize
you only need to
all
change this
the
because
System.
you
you need
want
to
to
initialize
initialize
all
all
with the solidus
you need
temperature.
to
Why?
initialize
Because
all
you
the
want
domain
the
with
PTM to be what?
the
To be
solidus temperature.
solid.
Why?
Solid. Yes.
Because
So
you
you need
want
to
the
initialize.
PTM to be
Right
what?
click
To
on the
be
initialize,
solid.
and you
So
say
you need
okay.
to
It
initialize.
will be
You
initialized.
right click
Okay.
on the
Okay.
initialize and you say
This
okay.
will be
It will
initialized
be
as
initialized. Okay.
all as called
This will be
solid.
initialized
There,
as
it do not
all as
deal with air. I mean,
called
only the beat
solidus.
solid.
There, you
Okay.
Go to
do
rank
not
calculation.
deal with
Now,
air. I mean, only the
go first
to
with
be
0.1
solidus. You go to rank
sec.
calculation.
And
Now,
put this as
go
a
first
method.
with 0.1
Okay.
second.
After
I
some,
can't
And
really
put
see
this
like
after
as
some,
what's
method.
the number of the time steps, please. I can't really see that
After
number.
some,
Like
After some
like the
number of time steps is 0.1.
no
0.1 second.
the other one where it's written
Number of time
number
steps is
of
0.1.
time step. Yes.
0.1 second. See, if you multiply this number by this number, you will get the whole time. If you multiply this number by this number, you will get the whole time. For example, I want to simulate 3 hours. I want to simulate 3 hours in second. I want to simulate 3 hours. How much 3 hours in second? This is 3. I mean every hour have 3 60 and 600.
Yes, exactly.
No, I mean every hour have 3 and 600
times it by
seconds, right?
This is 10,000 and
You times it by 3 seconds.
Yes.
This is
So
10,800 seconds.
If I wanted,
This is the total time.
put it in here.
So if I wanted,
to give me the number,
put it in here, you know, to make these two
on
things to give me this number.
it all depends on this.
See,
Yes.
it depends
you
on
want
this.
It
It all
point
depends
one.
on
That means
If
that
you
means
want
if I
the
this
step
time
size
this
to
will
be
be
0.1, that
So,
means
to get
that
this,
means
I will divide
if I
10
this
by
time this will be this.
Did you get
So
Yes.
to get this, I will divide the 10
the
by
first one
0.1.
times the second
Did
one
you get it?
will give you the total time.
So
Okay.
I mean the
So
first one
first
times
is
the
number
second
of
one
times that I
will
don't
give
know.
you the total
It is
time.
X.
So the first is the number of time steps. I don't know.
The second one is
It is
time step
X.
size, which is 0.1. I consider this by
Time.
myself.
The second one is the time step size, which is 0.1. I consider
Equal
this
to
by
the
myself.
time step, the total time I have
This is
is
one.
3 hours.
So is equal to
So
the
you
time
divide
step.
this by
The
this,
total
you
time
will
I
get
have is
Okay.
3 hours. So you divide
So
this by this, you will
divided
get
by
the X.
0.1. This is 1, 0,
So
8.
this divided by 0.1.
You
This
go
is
with 1,
108. Right. So you go with 1 and 0.8.
okay? 108.
108
But
and
But,
then
you can,
okay 108.
cannot
But
0.1
but
because
you
sometimes
can
stop the
see
solution
you
and then you
cannot
change it to
let's point one because
let's go
you
1.
sometimes stop the solution
After
and
some
then you change it
iterations,
to
let's say with the
let's
200
see let's go
iterations,
with one.
you stop the solution.
After
and you
some
make it as,
iterations, let's say with the
let's
200
10
iterations,
seconds.
you stop the solution
After 300,
and you make it as
400, another
let's
iteration,
10
you
seconds.
stop, you come over
After
here,
300,
say
400,
20
another
or 30.
iteration you
And
stop,
until
you come over
for
here
example, you reach
and say
60.
20
Okay.
or 30, and until
So,
you for example, you reach
when you stop
60.
the solution and
Okay.
change the time step size,
So,
when you come back
but
to the
when you stop the
to what
solution
this
and
one, you
change the
only
time step
say
size,
calculate. You don't.
when you come
go
back to the
initialize. You only
calculate
say calculate
to
and
what
you-
this one, you only say calculate. You don't
While if I
go
leave
to
it like this,
initialize. You
like
only say calculate
it's
and you
gonna take too long.
okay.
If I leave it to
It takes a lot of
Yeah.
time. It takes a lot of time. No, you don't need to do this.
It takes
lot
a
of
lot
time.
of time. It takes a
So
lot
if
of time.
If you
No, you
consider
don't need to do this.
0.1,
It takes a
so
lot of time.
It takes a
So
lot
if
of time.
if
to
you
complete
consider
C.
0.1,
I will
so
initialize.
it takes a lot of time to
As we
complete
said that,
C.
we have 0.1 and this one
I will
and
initialize.
this thing. Now we're gonna calculate.
As we said that we have
See?
0.1 and this
This
one
is gonna
and
go
this thing.
down
Now we're gonna
smoothly and perfect.
see
but
this
how,
is
how do
gonna
you
go down
translate
smoothly
those curve like
and
those
perfectly.
lines? Why
Let's
why they
go.
are going down? Sometimes they are straight.
Yeah, there are residuals. There are residuals. That means there are errors. The errors is
Yeah, there are
decreasing.
residuals. There are
Okay,
residuals.
okay.
That means
Yes.
there are
This is
errors.
the
The
number
errors
of
is
decrease of
decreasing.
the error.
The
It's,
errors is
you see
decreasing.
this points.
This is the number of decrease of the
3
error.
to
It's
the power of
you
minus.
see this points
Yes.
Okay, you need
6.
to
I mean 3
all
to the power
go
of minus
down
6.
like that.
Yes.
So they will
Okay,
they will
you
be
need to
all coming
all
down.
you know
to
go down
get
like
a
that.
minus or
So they
minor,
will be you know
error.
all coming
Okay,
down
this is for the
to
K of
get
the
a
month.
minus
Yes.
This
or
is for
minor
the energy.
error.
Yes.
This is the
Okay, this is
momentum,
for the
which
K
is
epsilon.
XY,
This is
and
for
this is for the
the
continuity.
energy.
If you
This is
read it
the
from here.
momentum,
Yes.
which is
Yes.
xy, and this is for the
Ah.
continuity. If you read it from here,
Jet.
you see? Ah,
Jet.
So these are the equations that are being solved.
Yes.
Do you know the continuity?
Yes.
These are the equations that are being solved.
So it is now.
Do you know the
being solved.
continuity?
So the
Continuity is going to be solved.
velocity, the
here.
momentum.
So it is now
Equation
being solved. So the
are
x,
being
y,
solved.
also the
Also,
velocity, the
inertia
momentum
equation is being solved. The
equations
epsilon of the turbulence
are being solved. Also
So
the
all
inertia
are
equation
solved.
is being
So now
solved.
you stop
The epsilon
at
of
the
the
end of
turbulence
the
flow
iteration.
is being
You
solved.
You
So
okay?
all are solved.
Go with
So now
one.
you stop at
You
the end of the
calculate,
iteration.
you say, okay?
You okay?
then
You go with one. You calculate. You say
iteration.
okay,
Yes.
and then
Okay, after
you
you
go with
some
some other iterations.
another one,
Okay,
300.
after you
Stop.
go with
Now you
300
come over here and say,
iterations, another
go
one,
with 10.
300.
Until
Please
you
stop.
reach,
Now you come over here and say, let's go with 10.
I'm sorry,
Until you reach
600.
600.
Okay. So
I'm sorry,
stop
until you
after
reach
three
60
300
sections.
iteration.
No, see,
Yes.
you see
These numbers?
Yes.
Numbers
No,
are iterations. You
So,
you see
one,
these
500.
these numbers?
See?
These
Yes.
numbers
One,
are
540.
iterations. So
1,560.
1 500,
One,
see?
500.
1 540,
Okay?
1,560,
I give
1
or from here.
500, 1 600.
No, from
Okay?
here. You see?
So
These are
see, I give you or from here you also know it
Yes.
from here. You see?
Yes, I can
These
see
are
the iterations.
you see
Okay.
them?
You can take this depend on me.
These are the iterations.
Okay?
Yes.
You
Have
can
a roll
you
for
can
it.
take this depend on me on this one.
Like
Okay? Have a rule for it. You can go with
at
you can go with this. Like
200
uh,
you can stop.
Yes.
At
Okay.
point
Yes. Yes.
One.
at 200 you can
At
stop
200 you make it one.
from point
Yes.
Okay.
one.
From 200 to 400 you make
At
it
200 you make it
10.
one.
Yeah.
From
Okay,
400
from 200 to 400 you
600,
make it
you make it
10. From
10.
400 to 600
From
you make it
600 to 800 you make it
20.
30.
Yes.
From
Then
600
2000
to
you make
800
40.
you make it 30.
Um
And then
400
2000
you
you make
make
it
it
40.
50.
400 you make it
800 you make it
50.
50. After that
Okay.
Yes.
you don't
Then
want
to
to stop
800
and,
you make it 60. After
run.
that
Okay,
you don't
need
want to stop
complete
and
the whole simulation with it.
and run. Okay, you need to complete the whole simulation with this.
But keep in mind, whenever you stop, okay?
But keep in mind, whenever you stop, okay, to change before you save it. See,
I wait
I
until
stop
it is
right
saved.
now.
Okay,
I
after
go
it
to
is saved,
save
now I change.
project.
So 20.
I wait until it is saved.
Now,
Okay,
I run
after
the
it is saved, now I
I run the
change
calculation.
to 20.
After
Now,
I made
I ran the
some
calculation.
iteration, I
I ran the
stop.
calculation.
Okay, now I save.
After I made some iteration, I
change.
stop. Okay,
Why?
now I save.
Sometimes, you know,
Okay, then I change.
sometimes
Why? Because
when
sometimes
now
you know
I save. Okay,
just
I change
focus
it to
on
30.
English.
Let's see.
Sometimes when
Let's
you
go
change
with 30.
from
As
20,
they calculate.
now I save it.
After
Okay,
similar
I change it to
iterations,
30.
the
Let's see.
residuals,
Let's go with 30. And
go
stay
down.
calculate.
The residuals will,
After
will
similar
grow.
iterations, the
understand what will work will
residuals
go
will not
all
go
up,
down.
and
The
the
residuals
solution
will,
will be
will
correct.
grow.
So,
You understand what will work will go all up, and the solution will be corrected.
broken and corrected.
So,
You cannot
it is
go
corrected.
back
The solution, if it is all broken,
cannot go
broken
back.
and corrected,
But
you cannot
as
cannot
you have
go
saved
back
it
to it.
before you change to 30.
You cannot
You
go
can,
back
what,
to it.
you can do
But
the following. You can come back
as
to
you have
the-
saved
the-
it
the
before you
project
change to 30,
with it.
you can what
New
you can
project,
do the
you say
following.
no.
You can
Do
come
not
back to
save
the
what you have already,
the project. You can
reached
go
to.
with this
You
new
understand?
project.
Do not
You
save
say
it.
no. Do not
Yes.
save what you have already reached
Be with
to.
me.
You understand? Do not save it.
Explain again. When we were in 20,
Be with me. Be with me.
okay,
Explain again.
after we
When
stopped
we
to make
were
it
in
30,
20,
we saved. So in the 20,
Okay.
it was okay. The
after we
solution was
stopped
okay,
to
right?
make it 30, we saved. So in the 20, it
You
was
can go back to
okay.
it
The
whenever
solution
you
was
want.
okay, right?
But when you changed to 30 and then made the simulation,
You can go
okay,
back to
and
it
then
whenever you want.
calculated.
But when you change
After
to
some
30 and then
iterations,
made
it
the
broke.
simulation,
The
okay, and then
solution
right
has corrected.
calculated,
After some iterations, it's broke. The solution has corrupted. Okay, so you cannot save, because if you save, you will what? You will save the corrupted file. You will not be able to get back to it. And if you got back to it, you will get back to a corrected file. The corrected file is not going to be, benefit for you. So what you want to do is only get out of the project and say no. After you say no, after you say no, already have a copy of it. I mean, we already. It is not safe now because we already have a copy of it. I mean, we already saved the twin. You can go back to file, to the last project you have. See, it will open. It will open from where? Do you remember? From the twin.
Right, sir.
Yeah, it will be open from the 20 seconds because I already saved the 20 seconds. I mean the work. Yeah, it will be open from the 20 seconds because I already saved the 20 seconds. I mean the work until the 20 seconds.
Yes.
It will be opening the work from 0.1 until the 20 seconds. So the simulation will be all. It is my work. This is my work. Now it is 60 because I didn't save. No, I didn't. I just. It is my work. This is my work. I'm speaking about you. Okay. So very quick. So the things that we already have. I want to explain to you something in very quick. The things that we already have. I mean, let's go with a little bit of run calculation in here. What we have got. These things that are in here.
Yes, sir.
You go to graphic. You go to graphic.
Yes.
To contour. You go to graphic. You go to graphic. You select contour. Temperature. Okay. You make a new contour. Say X. You select the temperature. Save this. Okay. You will have this one here. Okay. Say X. And then do not select. Make only say new. Save this. Like new contour. You will have this one. Okay. And select. And then solidification. Make another new. And then new contour. Okay. And select solidification from here. And then liquid diffraction. Close anything here. Say. Save display. You will be displaying the liquid and then close anything here. Say save display. You will be displaying the liquid diffraction. Okay.
Either air or
now, no. Do not.
Okay, sir.
Okay.
Okay, sir.
This things. Look. No. Do not. Go to rank calculation. This is this things. Look. This thing before even go to rank calculation. And then I already explained to you these things, but before you go with run, you need to do it, and then you come back to calculation activity. Will be one animation. Open the solution, say new. Okay. After you say new, will be one animation. This is the video of the animation. Okay. Say use active. Select the contour one. Okay. You make another select contour one. Say use active and okay. You make another new. Okay. You go to contour 2, use active, where are these videos? Select OK. After the simulation these is gonna be videos. Animation. Yes. Where are these videos? You can after the simulation is done, you can come back to an animation, playback. See. You can play it from the first. See. Oh, they are not saved. Oh my God. They're not saved. Why? Oh, they are not saved. Oh my God. They're not saved. Why? Oh. Why is it? Anyways, go back. Oh. Anyways, see. After you finish the simulation,
yes, sir.
You will see the graduation. After you finish the simulation, you will see the graduation of the temperature, all the liquid diffraction from where it is 0, from where it was solidus, until it is all melted. This is not all melted, right? There is some solidus here. So you can go with the simulation and complete the whole simulation until you get all as, red. That is all melted. And then you can come back over here, you select the animation one, and run it from here. You say play. It will be playing until you
so
see it all
for the
from the
whole
first time.
PCM to be melted. So I have to increase the time, or right? I have to increase the time or the temperature.
You want to increase the time or the temperature? I didn't understand you.
No, I mean like
You
if
want
I
to
want like
increase
the
the time
whole
or the temperature? I
meeting
didn't
to
understand
make
you. You need to go with more time.
more time. Okay, okay, sir. So what
Yeah.
I
You need to
can
go
see
with
a
more
line.
time.
What does line like mean? Like the
Yeah,
liquid friction.
until the finish. If you see the here,
Yes, sir.
because I have, if you see the here, so when you
Because
see,
I
see the liquid diffraction is coming up, right?
yes,
So
sir.
when you see fraction, so when you see the liquid diffraction
Yes.
is coming up, right? So when you see all these as red, that means that the liquid diffraction is completely shown in the PCM. That means the PCM is all
Yes,
melted.
sir.
You can
Yes,
stop
I got
the
it.
solution. You can stop and then save the project and go with it. In here, to see
You
this
got it?
one, to see the liquid diffraction in here,
Of the
to
simulation
see this one,
as it
to,
is
to
moving,
see
the time
the
flowing.
liquid
Yes. Okay.
diffraction
Yes.
of the simulation
But by the
as it
time
is
goes, we
moving,
can
the
go with
time
the liquid
flowing.
diffraction to see if
Okay.
it is still one or it is
Uh,
decreasing or
but by the
increasing.
time
So you
goes,
can
you
go
can
to
go with the
the
liquid diffraction
report
to see
definitions,
if it is still
new
one or it is decreasing
surface
or increasing.
report
So you can go to
area,
the
weighted
report
average, right?
definitions,
Or you can go
new
with volume. You
surface
can go with
report
volume, yes, volume
area
average.
weighted average,
You can
right?
select the
Or you can go
PCM
with
that is
volume.
we
You can
want,
go with
field
volume,
variable, we
volume
want the
average. You
solidification,
can
we
select the
want
PCM that
the
is
liquid
we
diffraction on
want
the PCM,
field
right?
variable, we want the
And we call it in here
solidification,
as
we
liquid
want the liquid diffraction on the PCM,
something
right?
like that.
And
Okay.
we call
So
it in
this
here
is
as
I want to
liquid
tell the answers that
frac,
I want you to give
something
me
like
the
that.
liquid
So,
diffraction
so
of the
this is, I
PCM
want to
yes, as
tell
the
the answers
time
that I
goes,
want you
right? I will
to
give
give
you that.
me the liquid
Okay. So
diffraction
right click.
of the PCM
We want
as the time
also, for
goes,
example, we
right?
want the
I will
outlet
give you
temperature.
that.
Yes.
Then
Yes.
right click. We want
New.
also,
Now
for
it's not
example, we
volume.
want
It
the
is
outlet
surface.
temperature.
Okay.
Right
Okay.
click.
Okay. Surface temperature. Area weighted.
New.
The
Now this
difference
is
is
not
that
volume. It is
the
surface.
outlet is a surface,
Okay.
while the
Surface temperature.
liquid
Area
diffraction we
weight.
want it on the
The
whole
difference is
volume
that
of the PCM,
the
right? So
outlet
we
is a
say
surface,
volume.
while the liquid
Volume.
diffraction we want it
So
on the
so should
whole
I
volume of the PCM, right?
okay?
So
So
we
should I
say
do it like
volume,
before calculation or
volume.
after?
But
Yes,
here
yes,
we want only
indeed. Before the calculation. Okay.
this is before even the initial. This is
Initialization.
yes, before yes, yes,
Even
yes,
you
yes, yes.
reach the
Before the
initialization. All right.
calculation.
All right.
This
So
is
right
before
click,
even the initial.
new,
This is before even you
surface
reach the
report,
initialization,
area
right?
weighted average.
So right
Say
click,
the temperature here,
new,
and
surface
you say
report,
surface type
area
here
weighted
to know
average. You
what
say
are
the
these
temperature
things.
here,
You go with
and
the outlet.
you
You tell it
say
as
surface
yeah,
type
I
here
want it
to know
temp
what are these things.
all
You
or
go
temp
with the
out,
outlet,
whatever you
you
want.
tell it
Okay,
as
yes.
yeah, I
And then
want
after
it
that, you
temp
say okay.
all
Now we
or
have
temp
a
out,
report,
whatever you want.
a
Okay,
graph
and
of
then
the
after
temperature
that,
and
he
the
say,
volume.
okay,
Do whatever
now
you
we
want.
have a
See, new.
report,
Yes.
a graph
Surface
for
report,
the
area
temperature
weighted
and the
average,
volume
and you
pressure.
will see
Do
whatever you
whatever you
want
want.
here.
See, new
And on whatever
surface
you want of the
report,
walls.
area weighted
Okay?
average, and you
Okay,
will
sir.
see whatever you want here,
And you
and
call it, and
on
then you
whatever
say
you
volume.
want of the walls. Okay,
So we have this one. So
and you call it, and then you say okay. So we have this
if
one.
you want
So
the Nusselt number or H,
if
yes,
you
sir, right?
want the
So you can go
Nusselt
with this. You
number
can go
or
with
H, right?
um
So you can
first you need
go
to
with this. You can
make
go with
a expression. Yes.
um
First
you
you need
need
to
to make
write
a expression.
is it shown in your answers? The
You need
named
to
expression?
write.
Do you have it in your
Is
answers?
it
First, yes,
shown in
I have
your
it. I have
answers?
it.
The named expression. Do you have it
Can
in
you
your
go
answers
to new
version?
right click new when you do it? You go to right click
Yes.
and then new.
Can you go to
Then
new
when you
right
go
click
to new,
new when
you
you
do
do
like
it?
that.
You go to right
You
click
do like that.
and then new.
You open.
Then when
You
you
will
go
be
to new,
opening this.
you do like
You
that.
say
See,
T
you go like that.
B. That
You
means
open.
T bulk,
You will be
right?
opening this.
Yes. TB. That means
You
T bulk.
say
This is the
T.
first thing we need.
The T bulk
B,
is
that means
299.7. This
right?
is the inlet temperature
TB,
of
that means T bulk. This is the first thing we
this
need.
is- The T bulk is 299.7. This is the inlet temperature
No,
of
this is
the
not the inlet
this is
inlet. It was 300.
I made it as 200.
No, this is not the
Anyways,
inlet temp.
You can go with
inlet.
this doesn't.
It was 300. I made it as 200.
Only
Anyways,
for a
you can go with
demonstration, okay?
this doesn't change anything of the simulation. This only for a demonstration.
Plus
Okay,
the
you go with
outlet
3 3
You know why I'm doing
15
that?
plus
Why?
the outlet temperature.
Do you know what is the? Do you know what is the?
You know why I'm doing that?
Yes, yes.
See.
The convective.
I mean, what
Do you know what is
what
the?
nus-
Do you know what
nuslet?
is the H?
Nuslet is H times D.
I mean, what is what is the nuslet?
Yes.
Nuslet. Nuslet is
We already
H
have D.
times
We
D
already have K of air,
over K.
but we don't have H.
Yes.
How do we get?
We already
H?
have D. We already have K of air, but we don't have H.
It is
How
like
do
that.
we get H?
H is equal to Q over
It is like that.
Q over
H
Q
is
wall
equal to Q
minus T
over
bulk.
Q over T
Yes.
wall minus
T bulk
T
is equal
bulk.
to inlet temperature plus
T bulk
outlet
is
temperature
equal to
divided
inlet
by
temperature
Okay. Yes.
plus
We have the inlet
outlet
temperature. We don't
temperature
have the outlet temperature. The
divided
answers
by
we
2.
calculated
Yes.
divided by 2. It will be over
We
here.
have the inlet
and
temperature.
then
We don't have the outlet
T wall
temperature.
we can
The answers will calculate
We
it
can also make
divided by
a,
2. It will be over
report
here.
for it.
And then
The surface
the T wall we can
calculate.
calculate it. We can
wall.
also make a
And
report for it
here,
for
and
the
this will
surface
also we make
temperature
a
of
report
the
for it. We
wall,
get the H
and
then here.
we put
See.
it in here, and the Q also we make a report
the
for
inlet
it.
temperature is
We
we
get
know.
the H.
We
then
don't know the
here.
outlet,
See.
so what we write.
CC. The inlet temperature is we know it.
Here?
We don't know the outlet, so
Have
what we
made a
write.
outlet temperature. Do you remember?
Do you
Right,
remember
new
what we have done
surface,
here?
area. And
We
then
have
say
made a
temperature,
outlet
and then we
temperature.
said,
Do you
out.
remember? Right click,
Yes.
new surface, area,
Remember
and
the-
then
the-
we
the
say
call- the
temperature, and
calling,
then we
the-
said
remember
out.
the name of
Okay.
it. What was the name?
Remember
was
the
the-
the call the calling. Remember the name of it. What was the name?
Right?
Yes.
Temp out.
The name
so
was
we
here.
already
Here it is,
made
here,
a
here.
report for it. We can call it from here. from
Temp
the
out,
expression.
right?
We always
Temp
say-
out. So we already
we always
made
say
a report for it.
temp.
We can call it from
When
here,
you say
from the
temp-
expression.
No,
We
in,
only say CC. We only say temp. When you say temp, no, in see. We say
No, it is
temp.
small.
When you say temp,
See,
it
is shown, right?
Yes. Yes. I
No,
get
it is in small.
Temp out.
Temp.
So
See.
we say this.
It is
plus this
shown, right?
between two brackets and divided by 2.
Temp out.
We call the T
So
bar.
you say this plus this
That's great.
between two
We say,
brackets
okay,
and divided by 2, we call the
say,
T-bulk.
okay,
This
only
is the
for
first thing we got
that's
it.
great.
That's great. You say
Now,
okay,
what we want
and
to do is
you say okay only for it,
we need
and that's
the
great.
Q, right?
Now what we
Q plus.
want to do is
We already said
um,
that H
we
is
need
Q flux
the Q,
divided by Q wall
right?
minus T bulk.
the Q flux.
So, we got
Because
the
we
Q
already
flux
said that
Q.
H
We
is
already
Q
go
flux
to
divided by
the
T wall
same
minus
thing.
T bulk.
Go to this new
So we got the
surface
T bulk,
report.
so it is the Q.
Area
We
weight.
already got
And then
the
from
same
here,
thing. We go to this new surface
wall
report,
flux.
area weighted,
And then
and then
go
from here
to the total
wall
surface heat
flux,
flux.
and
And
then
then
we go
we
to
choose
the
cup. Because we
to
need
the
only
total surface heat flux,
right?
and then we choose the couple because we
And
need
then
the
we
heat
call
flux
it
on the
Q or
surface
whatever
of
you
the
want.
wall,
And then
right?
So now the total flux
And then we
is
call it
also
Q or whatever you
done.
want, and then okay.
It's Q flux.
So now
we
the total
only
flux
need the
is
Q.
also
We only need
done.
the Q, right?
It is Q flux.
New
So
surface
we
report,
only
area
need
weighted
the
average,
T wall. We only need the
And
T
now
wall.
we
Right
want
click,
the
new
outlet. We take the
surface
couple
report,
because
area
we want
weighted average,
wall.
temperature,
Also
and
give it
now
a
we
name.
don't take the outlet. We
So,
take the couple because
have
we
Q
want
flux,
the T wall.
The outlet.
You also
We
give it a
get
name.
the T bulk from it.
Yes.
We show the T.
We have Q flux, we have T out, we get the T bulk from it. We have the T, the
Hello, sir.
temperature of the wall.
Okay. Okay.
The H is Q flux.
temperature of the wall.
See, take Q. It is Q flux. Okay, we
The H
select it.
is Q flux
T-wall.
C.
We already made the T-wall
Say
here
Q.
in the report.
It is Q plus. Okay, we select it.
Divided by.
Where is it? T-wall. We already made the T-wall here in the report.
T-bulk.
So we say
T.
T-bulk is here.
Where is it? Where is it? Where is it? Yeah.
T-wall minus. We want the T-bulk.
Yeah.
T-bulk is here. We made it in
Be
here.
aware of the capital
Go
or
with
small
T.
letters.
Okay, here are all small
yeah,
letters.
that
And here we can go with capital or
Be aware of
Now
the
close
capital
this
or
bracket.
small letters.
Okay, here are only small letters. And here we can go with capital or small.
green, now close this
Yes.
bracket.
If it is green,
We
it is
good.
If it is not
We
green, it's
good.
not okay.
If it is green,
green,
if it is green, it is
equation. If it is not green, it's not
So,
okay. Then
when you
we
close,
go
it's
with
all
okay.
going to be green, and
Yeah.
that's okay. Okay, that means the equation is okay.
This is
So then you
right
go with
click
okay.
new. Another equation.
New.
For
This
what?
one, okay.
For the no.
This is
Okay.
You say that.
right click new. Another
Nuslet is
equation.
HG
For what?
overcase.
For
So you
the
say
nuslet.
Here is the
You say that. H.
that we have already.
Nuslet
made.
is
Okay?
HD
This is
over
it.
K. So you
Time.
say F. Here's the
and number 8.
that we have already made. Okay? This is the time.
8
Shift
and you
and
open
number 8 will
these
give
brackets
times.
that are
0.08
say meter.
and you
need to
open
put the
these
unit.
brackets
It
that
doesn't
are
fit that.
square and
So,
say
divided by-
meter. You need to put
What
the,
was
the
the
unit. It doesn't
0.024?
fit
This is
that.
the conductivity.
So divided
And
by
open it.
what was
NW,
the
I mean, this is gonna be
0.024? This
capital.
is the conductivity,
Should be capital.
and you open
Divided
it.
by
Shift and W.
meter.
I mean, this is gonna be capital. This should be
Also
capital.
divided by K.
Divided by meter. Also
You make it
divided
like
by
that.
K.
W
Think-
by meter by K.
Take that.
This is watt per meter
Yeah.
cubic. This is the conductivity.
You make it like that. W by
And
meter by K.
They
This is
also-
watt
okay.
per meter cubic. This is the
So we have the
conductivity unit.
nuslet and the edge.
And then you say also okay.
Okay.
So we have the nutlet
Just
and
be,
the edge.
aware of that. In the
Okay.
report definition,
C.
these are
Just
all
be
gonna
aware
be
of that.
right?
In the report
Okay.
definition, these
Because they
are all gonna be
already
here.
a report definition.
Or
so
gonna be
they
here,
are
right? Or gonna be
in
here.
the report file.
Because they are all already a
False.
report
So
definition.
these
So
are all
they are
gonna be
in
placed
here.
in here
Report
to be
files
filed
and
and to be
report
plots.
plots.
To be
So
plots like that,
these
and to
are
be
all
files that
gonna
can
be placed in here to be
already
files
saved
and to
to
be
a,
plots. To be plots like that and
So
to be files that
If
is
you notice
saved.
that all these
already
things
saved
in
to
the
a,
report definition, but the
folder.
nuslet and edge
So,
is not.
If
I
you
mean,
notice
okay,
that
I
all these
already
things
made
in the
them,
report definition,
but
but the
at
nuslet
first
and
they are
edge
not.
is
So
not.
what you do is
I mean,
you
okay,
go to-
I already made
I mean,
them,
what is not?
but
I mean, they are
at the
not
first they are not.
shown
So what you
whenever
do is
go with the
you go
time.
to.
Okay.
Only
I mean,
the
what
Q
is not?
fluctuate.
I mean, they are
Temperature
not
go with time,
shown
The
whenever you
temporal
go with the
W,
time.
The lick fraction,
Only the Q
but
fluctuates. The
edge
temperature
and nuslet
go with time,
is
yeah.
not because
The
we made
temporal
them
W,
here in the name
the lick
expression.
fraction,
We
yeah.
didn't include
But
them in the
edge
report.
and nuslet
How do we
is
include?
not because we
Go to
made them
right click.
here in the name expression.
New.
We didn't
Now you don't
include
go
them in the
here.
report.
Go
How
to
do we include?
expression.
You go to right click, new.
So
now you don't
want
go to
what?
there.
You know,
Go to
you want
expression.
edge. Okay, say edge
Yes.
and
So now you want what?
Let's
You
go
know
with
you want an edge.
something like
Okay, say edge
only
and
right edge.
a coefficient.
Okay,
Let's
this is
let's
the
go
edge.
with this
I
number.
want it to be
Something like
a
that.
report definition.
Only
Say okay.
right edge. Okay, this is the
Right
edge.
click.
I want it to
New.
be a report
Expression.
definition.
I
Say
want the
okay.
nusselt number.
Yes.
So
Okay.
I write
Right click.
nusselt number.
New
Mm,
expression. I want the nusselt
like
number. So I write
NU.
nusselt number.
It is here.
Okay, you can
Like
go
that.
with okay. So and then we
So,
say NU.
this
It is here.
and edge coefficient are now
Okay, you can go
included
with okay.
in the
So-
report
So
definition. to be
you
here
see
shown.
this? Nusselt and edge coefficient are
After
now
doing all
included
these
in the
things,
report
what you
definition
need
to be
do
here
is
shown.
Go to initialization. You
After
select
doing
formula,
all these
and then
things, what you
give,
need to do is only
299,
go to
you
initialization,
also go
you select
initialize,
formula, and then
go okay.
you give 299 to be all solid. You go
put these things
initialize,
up, already
go
made,
okay,
and
go
then
to rank calculation. You put these
Sorry.
things up. You put it
like
already
that, and
made,
then you calculate.
and then okay.
When you calculate,
I'm sorry. You put it like that, and then you calculate.
when you start calculating,
When you calculate, see the concept.
see this is completely
start
red, and this
calculation,
is completely blue. That means this is
see the
completely
concept.
fluid, and this is completely
See, this is
solid.
completely red,
You
and this is
understand that?
completely blue. That means this is completely
These
fluid,
are gonna
and this
be
is completely
all,
solid.
You understand that? Gonna be gradually going up the rate. These are gonna be only, gonna be gradually going up the rate. That means that the fraction of liquid is gonna be shown in here. That means the solid is gonna be melted. And let's go with the temperature. This is also the temperature. No, this is where's the temperature? You can go check them later. See. This is the liquid temperature. Anyways, you can go check them later. See, this is the Q plot. This is the Nusselt number. See, Nusselt number. Outlet wall. This is the coefficient of it. Outlet. See, this is the temperature of outlet wall.
After that,
Temperature of
edge
outlet.
temperature
See,
for the edge curve.
after
Wanna
that,
see something?
this is the temperature.
Yes. The edge coefficient.
This is the temperature. This is the wall temperature. See, this is the wall temperature.
Okay.
And this is the outlet.
Okay.
This is the wall temperature. See, this is the wall temperature. And this is the outlet temperature. This is the outlet temperature. Okay. You can go with where is the edge? This is edge. This is edge, and this is temperature. With time, this is with time. After you reach the 60,
Yes.
you complete it until you see that this is it. After you reach the 60, you complete it until you see that this is all. Where is it? Do you see that? See, this is the temperature. Why? Because it is pretty red. That means hot, and then it's getting a little bit colder. Why? Because it sucks and takes the heat, the coldness from the PCM and gives it its heat. The air gives its heat to the PCM that is going to be a little bit cold. You see it? Whatever you want.
Okay.
Until it melts the whole PCM. After that, you can go with whatever you want. See it? If you play, this is you can see. See it? If you play it, this means the air goes like that. And after you make this is only 39. This means the air goes like that. And after you make this is only 39 frames. Because of the time if you go with 100 frames, 800,000 frames. Because of the time that you go, you will see the complete melting of the PCM from the start until the end. Okay, that's it.
Yes, I got it. I got it, sir.
So my family is, they're shouting on me to go to eat. I haven't eaten. So my family is, they're shouting on me to go to eat. I haven't eaten.
May Allah
till
bless
now.
you and your family.
You're welcome.
Thanks a lot. See, what I want to do is, I want to, I think it is pretty heavy. Thanks a lot. See, what I want to do is, I think it is pretty heavy, CCC. But I want to do something. I think that I can give you, I send you the project if I could, but you need to initialize and run it by yourself. See how much is it. It is set. I think I made initialize it. Let's go back. 75 megabytes. Wait, it was more. I think I made initialize it. Let's go back. Let's go back. No, it's not like that. Did I make? I think. Wait. No, it's not like that. I think. It was 7 gigabytes. Wait. I have made initialization for it.
Yes,
It was 7 gigabytes because I think. Anyways,
I
will send you this file.
Yes.
Anyways, I will send you this file. Yeah, open it on your own computer, and what you do is only run the calculation, right? You open it on your own computer, and what you do is only run the calculation, right? You only need to run the calculation and do the as I told you. Start from see. I will initialize. I will go initialize it. 1 second. I will initialize. Then I will go with 1 second. Some minutes. Some iterations. Until they are some minutes. Some iterations. They are until they are good like that. Okay, good. Let's go. Let's see if they are all good. Let's go with this is the temperature. This is fraction. And this is temperature. Right. Good. So
This
what I
is the
want
temperature,
is
right? This is
I wanna
fraction,
save
I
it
mean.
like that.
And this is temperature, right? Good.
I want to only
So
save it like
what
that.
I want is,
That's good.
I want to save it like
Now,
that. Get out of it.
I want to only save it like that.
So
That's good.
now
Now
let's
let's
get out of it.
size. Yeah, it is 51. Great.
So
I will compress it.
let's see how much
Add
is
it to our
the
card.
size. Yeah, it is 51.
Fantastic.
Great. I will
And I will
compress
send
it.
you by
Add it to our
let's
archive.
go with by mathematics.
Fantastic. And I will send you by,
I can send you my
okay,
my
let's
email
go with
address
by
on
messenger,
Facebook.
for example.
Okay, send me your email
Okay.
address. I will send you on the email. Then
Okay, send me
then
your
you can
email
go
address. I will send
open
you
it
on the
and
email.
do
Then
as I
then
taught you.
Yes,
The
sir.
the
then you can go
open it and do
changing
the as I have
Sir,
taught you.
thank you so
The
much for your time. Thank you so
iterations
much.
and changing
You
the
really
time
saved my
size.
life.
You're welcome, bro. I have gone through this thing before, you know.
Yes,
I've gone through this
You're
thing
welcome,
before,
bro.
I was, you know,
have gone
fresh and
through
don't
this
know about
thing
ANSYS.
before, you know.
So
I have gone
whenever
through
I
this
was,
thing
you know,
before, as
posting,
I was,
please
you know,
help me,
fresh and
please,
don't know
I do
about
need some
answers.
help and
So whenever
a lot
I
of them
was, you
are,
know,
you know, giving
posting,
you these
please help me,
cold
please,
shoulders
I
and
do
do
need
not
some
care
help,
about
and
you. So
no,
yes.
a lot
I
of
know
them
about
are,
this.
you know,
All
give
of
you
them,
the
they were just asking
cold
me money
shoulders
about
and do
that.
not
Thank
care
you so
about you.
much.
So
If you don't know how
It's
I
to
know
not
do
all
about
it,
these
about money,
things.
bro. It's not all
yes,
about money.
yes. Thank you.
Yeah,
God bless
yeah,
you.
it's not all about money, bro.
And
It's
how
not
how
all
Allah
about
will
money.
really
Only
bless you.
Thanks.
Thank you
Anyway,
so much for your time.
welcome.
And
Anything
I
you want,
sent you my
only
email
send me an
address
email.
on Facebook. So
Thanks.
Okay, great.
Thanks a lot.
Inshallah, I will send you. Inshallah. Thanks a lot, bro.
thank you so much. Thank you so
You're
much.
welcome. You're welcome, bro.
Okay,
You're
great.
welcome.
Inshallah,
Have
I
a
will
nice
send
day.
you.
Inshallah.
Thank you so much.
Thanks a
Goodbye.
lot, bro.
Bye, sir. Thank you.
You're welcome, brother. You're welcome. Have a nice day. Goodbye. Bye.